Now here are our last few examples. We start off with 2x squared minus 5x minus 3 equals 0. So again, we want to factor this. We factored this by grouping before. So we had 2 times the negative 3. That gave us negative 6. We want the factors of negative 6 that add to negative 5. That would be a negative 6 and a positive 1. So I'm going to split the middle term to be negative 6x and positive 1x. I still have the 2x squared and the minus 3. Now I factor by grouping. I group the first two terms together and the last two terms together. Out of the first set, I factor out the greatest common factor, which is 2x. When I divide out the 2x, out of the first term I'm left with x, and out of the second term I'm left with negative 3. From the second set of terms, there's nothing in common, so I just put a positive 1. When I divide them both by positive 1, I'm left with an x and a minus 3. Now notice that my greatest common factor now is x minus 3. So when I factor out an x minus 3, I divide the x minus 3 out from this one and I have 2x. And from this term over here I have plus 1. So factoring, I have x minus 3 and 2x plus 1. Now, because this equals 0, I set both of these factors equal to 0. So adding the 3 over, I get x equals 3. On the second part, the second equation, I'm going to subtract the 1 and then divide by the 2. So x equals 3 or x equals negative 1/2 are my solutions for this problem. Now these last two problems look a little bit different because they have fractional exponents. When you have fractional exponents, remember that the top number in the exponent, this is the power, or in other words, it's being raised to the second power. The bottom number of the fraction is the root, or in other words, this one is going to take the third root. So we have x plus 2 being raised to the second power and then taking the third root. So what we want to do to get rid of this is we want to say if I have x plus 2 and it's got the third root and it's being raised to the second power, I can rewrite this left side like this, the third root and the second power. Now I can just work with the powers and the roots and get rid of them by doing the opposite. To get rid of the raised to the second power, or in other words squared, I would have to take the square root of both sides. Which means now I have the third root of x plus 2, and that is equal to, now don't forget that when you square root something, you always have the positive and the negative version of it. So the square root of 25 is 5, it could have been positive or negative. Now to get rid of the third root, I need to raise this to the third power. So I'm going to raise the right side to the third power as well. On the left side, the third root and the third power cancel each other and I just get x plus 2. On the right side, 5 raised to the third power is 125. So that could have been positive or negative. Now all I have to do is subtract 2, so I have x is equal to this thing subtract 2. And I'm just going to put the subtract 2 in front of it. So it's negative 2 plus or minus 125. Which means that if I had negative 2 plus 125, I'd get 123. And if I had negative 2 minus 125, I would get negative 127. Now we do have to just check real quick to make sure that these work, because remember that you can't take the square root of a negative number which in this case, we're taking the third root, not a square root. So both of these would be correct solutions. If this 2 had been on bottom, then we couldn't actually square root a negative number. But we can always square a negative number, and we can always take the third root of a negative number. Here's your second example like that. It's raised to the 3/4 power. Or in other words, the 3 is the power and the 4 is the root. So I could rewrite this as the 4th root of x minus 3, and that is being raised to the 3rd power, and that's supposed to equal 8. So now I would have to take the 3rd root of both sides to get rid of the 3rd power. So I'm left with the 4th root of x minus 3, and that equals 2. Now, to get rid of the 4th root, I need to raise it to the 4th power. So I raise both of them to the 4th power. I now have x minus 3 equals 16. Now, because I took the 3rd root, it doesn't change, it doesn't have the plus or minus. And because I raised it to the 4th power, it still doesn't have the plus or minus. Now all I have to do is add 3 to both sides, and I get the answer that x is 19.